you, Simon. So my name is J.B. Straubel. Maybe just to reintroduce myself also. I'm a co-founder of Tesla, along with Elon and several others, and the longtime CTO there for about 15 years. And humbly, I would say, I think we would still be here today, even if we hadn't built that first Gigafactory. We just might not be here quite as quickly. And I think that's one of the things that I'm proud that we were able to do at Tesla, is to accelerate this and bring more attention to this. But Simon and I will talk a bit more about that in a few moments. I wanted to share a little bit about what I'm working on today. I'm today the CEO and founder of a company called REDWOOD Materials. We are a battery materials company focusing on building a circular supply chain for battery materials. But even before, I'd say, diving into the details of what REDWOOD is doing, I wanted to zoom out a little bit and kind of remind us why we're all here. Why are we talking about building terawatt hours of battery supply? Why is this so important? Why are we going through all this crazy effort to dig up, lithium and nickel and everything else? And I think it's really key to remember that we have a bigger imperative of how do we, solve the issue of global, CO2 concentration in the atmosphere. That's really why we're talking about electrifying everything. That's why, gigafactories are relevant. That's why electric vehicles are relevant. And this is, I think, probably the most clear data that we all have to keep in mind. The CO2 concentration. We've seen many different movies and slides and presentations on this, but it's just not slowing down. It's kind of, alternately terrifying and sometimes demoralizing, sometimes, inspiring to me to really think about this stuff and the magnitude of the challenge in front of us. But we have to electrify literally everything we do. Every part of our economy, every part of our society has to not burn fossil fuels. And it's kind of incredible when you think of that and you go through your daily life and how many times that touches everything we do. But it's a massive undertaking. So this, along with all the other challenges to make that supply chain work, I think are really one of the challenges of our whole generation. It's a fun time to be an engineer solving this. So at REDWOOD, our goal is to help create this circular economy, to make battery materials more sustainable, to make the industry that's kind of behind the lithium-ion battery more sustainable. Our main focus areas, and this is very relevant to the things Simon just introduced, are how do we increase the overall supply of battery materials? We simply don't have enough right now. So expanding the supply base, also reducing cost. This is something kind of taken for granted. I'm sure many people in this room, dealt with this, for a lot of their career, but it's a bit taken for granted that lithium battery costs are just going to keep declining. Everyone shows these kind of, Moore's Law type equivalent curves, even though it's not really equivalent, but there is this imperative to reduce cost, to get them into the markets where they need to be. Recycling and localizing supply chain, creating circular supply chains, in my view, is going to be one of the biggest long-term cost reduction drivers. There's a lot of other aspects, but I think this will be one of the biggest as raw materials become the majority of lithium-ion cost. And finally, how do we reduce environmental impacts of those batteries? This, again, is, I think, a really important point not to lose sight of. Because if we remember the bigger goal of why are we electrifying everything, why are we trying to make so many EVs in the first place, we're trying to reduce CO2, we're trying to reduce fossil fuel combustion. Well, if there's enough embedded emissions in the batteries and the way that we go about making these things and refining the nickel and refining the lithium and moving it all over the planet, we have to be a little bit careful that we're not, chasing our tail here and moving emissions from one bucket to another. So keeping a very close watch on the actual CO2 emissions, which are never going to be zero, but tracking them and trying to minimize them as we make batteries and as we solve the supply chain challenges, as we do more mining and more recycling, is really important. And this is something we're very focused on at REDWOOD, creating key metrics and tracking the CO2 content of the critical battery materials. You've seen a lot of these graphs. I won't spend much time on this. I think Simon's are quite compelling as well. But the battery industry growth over the last 10 to 15 years is truly unprecedented. It's something like 500%, just looking out over the last 10 years, toward 2030. But if you go all the way back to 2015, and maybe 1 or 2 years before, as Simon was saying, when we first started to conceive of the first Gigafactory, and looking from then until about 2030, it's well over 1,000% growth. And this is a huge industrial part of our society and economy. There's not very many things grow this quickly that are this big. So it's quite an unprecedented time. And I also feel that the nature of the problems are really shifting toward industrialization. In the first generation of this whole movement toward electrification and batteries, there were more technical challenges. Could we make the batteries work? Could we keep them from catching fire? Was the lifetime sufficient? Now we've shifted, I think, into a much different realm of focusing on how do we make enough of them? How do we solve the problems of scale? How do we double, triple, quadruple capacity of all these critical materials and the batteries themselves, and do that while reducing cost? These are really the key problems of the next 5 to 10 years. Less so, will the battery have higher energy density, or will it last another few years? And of course, all those same raw materials that were mentioned before, there's a key shortage that we're going to see in almost every one of these different elements. One of the interesting pieces that we've tried to highlight a little bit here is looking at the gap that recycled supply can bridge. And I agree with some of the comments before. We can't recycle our way, to a whole new, EV industry. The physics don't work. You can't recycle something that doesn't exist yet. However, every year that goes by, we will have more and more recycled material content available in the market. And if we look far enough into the future, and maybe it seems like science fiction today, sitting here, of how can we get to this future state where all of the cars are electric, and where we have made the whole industry electric, these materials will be mostly in a closed loop. It's very different than petroleum, and this is just totally a different intuition. Many people, it's hard to grasp this, but all the battery metals that we have to mine and put into lithium-ion batteries don't get consumed in the application. It seems very obvious. Probably many of you guys understand this in the math, but when you really think of what it means for that industry, if you fast forward, let's say 50 years, when all the cars are electric, they've been electric for 5 or 10 years, and now we're not needing to mine these new materials. It's going to be a massive transition into a closed-loop economy where everything is remanufactured, collected, and re-refined, but not mined. So we have a whole generational problem of how do we mine enough materials to build the fleet in the first place, but it will absolutely, inevitably, I'm 100% sure of this, transition into a closed-loop economy. So part of what we're trying to do is help architect that. Maybe it's too early, maybe it's ahead of time, but trying to architect that and maneuver toward it in a logical and predictable way so that we can end up in the place we want to be with the lowest emissions and the lowest cost. Today, this supply chain, if you, again, look at that whole critical mineral supply chain, the movement of materials and mining all over the world as they kind of come together to form a lithium-ion battery, it is complex. It's complex, and it encompasses a lot of miles of transportation and a lot of emissions. There's also the time value of all these materials moving through maybe 3 to 6 months of supply chain time. So you have to invest, essentially, someone has to invest in owning that atom of lithium, even as it originates in South America, and then has to make its way probably to China for some refining and conversion, then perhaps to Japan or Korea for inclusion into a cathode, and then it might move to North America or Europe to make itself into an electrode and into a battery and finally into a car. So if you ride along on that atom, it might travel tens of thousands of miles on average. And that was just lithium. Nickel is coming from perhaps Russia, perhaps Indonesia, maybe Australia or Canada. This market is very far-flung and not collapsed, and I'd say not really rationalized for the sort of industrial scale of electric storage today. It's a little bit derivative from even way back when consumer electronics was driving this market, and it's also being driven by a very strategic investment from Asia. The Asians understand this is an important industry, and they're investing and planning appropriately. So our focus at Redwood is to think of how do we break that very, very dispersed supply chain. And having a recycled feedstock, at least a part of that percent of feedstock from the markets where the products exist already, gives an opportunity to break that giant geographic loop. Geology we can't fix. The elements occur where they occur in Earth's crust. That's something that we're not going to change. But once we mine them once and we move them to the market where the customers want to use them, then we have a chance to keep them there. And we can reduce that transportation need dramatically. So once we've mined nickel, once we've mined lithium and moved it to, let's say, North America, it would be really foolish to collect it, recycle it, and then send it all the way back halfway across the planet and do that whole journey one more time. We don't need to do that. So our goal is to link collection, logistics, diagnostics, checking about repairing batteries before we recycle them, then recycling, refining, and remanufacturing of battery materials, all in a geographic, tight location. You know, in my view, this is kind of the new gigafactory that we have to start articulating and understanding. You know, one analogy I've tried to use or thought of in the past is that, you know, the battery production supply chain feels a bit like an iceberg to me. You know, you see an EV on the surface of the iceberg and, you know, it's this big flashy product, everyone's excited about it. And it's not intuitive how much work and how much goes into the supply chain below that vehicle. And, you know, the nickel, the lithium, cobalt, the raw materials and the components within that battery make up the majority of the humans involved, the majority of the capital investment needed. So our goal is to, again, collapse this supply chain, link it geographically close. If you kind of think of our flow sheet of what we're trying to do in our company, we're pulling together things like cell manufacturing byproducts, which is a big part of the recycled stream today. It's not all old EV batteries. It's actually quite a lot of, you know, not very sexy scrap that comes from the recycling process when you make a lithium-ion battery. Close to perhaps 10% of the elements that enter that production process drop out of it before they become a good battery, or a good cell, I should say. Then we also blend that with end-of-life batteries, both consumer and EV, as well as all other types, mixed with raw materials, sustainable raw materials, newly mined. So we're not 100% focused on recycling. You have to blend these two. Then we go through a whole process of collection, storage, battery sorting, calcination, mechanical separation, linking that again into hydrometallurgy for refining of the metal salts, copper sulfates, nickel sulfates, and lithium. And the main piece that we're spending a lot of our resources on right now is remanufacturing, so that we can truly close the loop and keep these materials local. And the majority of our focus, you know, well more than 50% right now, is focused on this battery material manufacturing of anode copper foil and cathode material. And amazingly, many people in the automotive industry still don't understand, I would say, these components as well as they need to. You know, these are some of the most expensive components inside of an EV. Cathode is literally the single most expensive component in an EV, and so many OEMs don't even really understand what a cathode is yet. But between the cathode and the anode copper foil are included almost all of those critical metals that Simon mentioned in the beginning. So it includes all of the nickel, all of the cobalt, all the lithium, manganese if there is any in the chemistry, as well as the copper. You know, the only thing left out of that is graphite, you know, coated on the anode, and even that's, I'd say, you know, more substitutional and likely to change sooner. So this is part of why, you know, we want to go all the way to material battery component manufacturing, is to keep that material local and to keep it in a tight closed loop. Now this is looking at a little bit different pie chart than was shown in the beginning. This is the cost of those overall components, the bill of material components. And the cathode itself, well more than 50% of the cost of a lithium-ion battery. So that single component is more than half the cost. That's kind of hard to sort of digest and think about. When we imagine the Gigafactory, you know, and all of this, the hundreds of Gigafactories coming all over the world, those are really encompassing the kind of shaded areas. And I'm sorry, it's kind of hard to read the writing here, but up here is operating expense for the Gigafactory. You know, this is capital depreciation. So those are really what the Gigafactory is. And you can see again today, it's quite less than 50%. Maybe it's 30 to 40% of the cost structure is what we typically think of a Gigafactory. This picture was radically inverted 10 years ago. You know, it took a lot more cost to assemble the battery, and that was really the reason that we went after the first Gigafactory. One of the main reasons was to reduce the cost faster by accelerating the scale. Well, that did somewhat work, and now we see this cost picture where the bill of materials has taken over, and the components that have to be purchased into a Gigafactory dominate the cell price. So focusing on cathode and anode, in my view, is the only way we're going to keep reducing the cost of a lithium-ion battery. You can't keep doing it by making the gigafactories bigger and more efficient. Even if you made them really zero cost, you'd still end up with something that's above most cost targets for lithium-ion batteries by the end of this decade. So again, a key focus has to be cathode and anode. This is what we're building today. We're embarking on a pretty ambitious battery materials campus. This is not a gigafactory. We don't build cells, but we build all the components that go into cells. And in my view, this is one of the missing pieces, especially in the US and largely in Europe as well, is that we don't have really any industry to make the components for a lithium-ion battery. If you put a new gigafactory today, here in Washington, D.C. or something, you would import almost all of those components from Asia, somewhere in Asia. And that, can work, but it's also not a great situation when you're trying to manage supply chain, when you're trying to manage cost, and when you're trying to manage the emissions of that supply chain as well. So we're focused on building this campus that includes both anode copper foil, cathode production, and recycling and refining all in one location. And we can gain a lot of efficiencies and a lot of synergies from linking these operations together. There's multiple steps where you don't have to crystallize something and package it and send it somewhere. You can keep it as a solution and move it from one stage in the process to another. So it's kind of zooming out and thinking of how do we most efficiently do this. There are already, some companies in China that are beginning to think this way and are implementing things like this. So I'd love to say we're the only ones in the world doing it, but we're not. I think we're very much the leading edge in North America and the Western world, building this. And even at these scales, it's really more is needed. We're trying to grow as fast as we possibly can, and I think these are pretty ambitious goals. We're targeting, 100 gigawatt hours per year of these materials, production of these materials by about 2025. That's still only about 1 million EVs per year. So 100 gigawatt hours seems, in a gigafactory scale, it's maybe 2 or 3, depending on what's a nominal gigafactory today. But it's really still a drop in the bucket of what's needed in these markets. By the end of this decade, by 2030, we're aiming for about 500 gigawatt hours per year of production. Growing again as fast as we possibly can, but this is still a small fraction of just the need in North America alone. The global market, as was noted, is terawatt hours per year. So it's going to take many companies doing something like this in just North America to balance the market and to balance the need. With that, maybe I'll show a quick video here of what's going on at Redwood. Do we have any sound on this, perhaps? This is, I think, a bit of an overview just to see a sense of what we're building today and what's working today.
So we're going to have just a casual chat and get some input from the audience as well. There's questions on the app, by the way, which then there's a question, you can plug it on the app and ask the questions. There will be a mic roving around as well, but I just wanted to kick off actually with some philosophy, if that's all right, because it is 9 a.m. on a Thursday morning.
It's a good time for it.
Yeah. What is a battery recycling company? As broad as that. What actually is a battery recycling company?
Well, I think it's tricky to define right now. The whole industry is trying to sort out what is the scope of recycling, what is the scope of the supply chain involved in that. I know there's multiple companies working on this, and we need all of them and more. In my view, I think it needs to be something where, a recycling company is focused on, a particular part of the market and, closely integrated with certain partners. For us, I think of us almost more as a battery materials company than a recycling company. And, I believe we'll end up partnering with a number of different recycling companies, almost as mining companies. I think recyclers will eventually become a somewhat substitute for mining companies as we kind of move further and further into the future and get a bigger and bigger fleet of vehicles on the road.
So you foresee yourself, it's interesting seeing that new battery materials campus, because you're right, normally the industry would associate recycling with a downstream process, with a gigafactory or a smaller production facility. But actually, seeing something like that, it feels like you're far more upstream and you're going in the opposite direction to downstream.
Well, I think both directions are needed. We have to figure out how we can get that closed loop all the way from collecting a battery, where the vehicle has reached its end of life, whether it's a scrapyard or a junkyard or whatnot, all the way back to deploying those materials into a cell assembly facility again. And this is not really the sexy part of the supply chain, by the way. I mean, all of us are here because we're excited about it, but I hope. But in many circles, this is kind of seen as the dirty, underneath the surface, mining, recycling, garbage. People don't think about it very much. But it's really obviously extraordinarily critical, and even more so when it kind of gets ignored in terms of capital application and investment and growth.
When you devised, because I came out to see you in 2019, right, before the pandemic, and when you were devising the concept of REDWOOD and the position, the challenge you wanted to solve, the position you wanted to play in the market, how much of it was from a battery perspective? How much thought process went in from a battery perspective, or did you actually have to think like a minerals and mining and chemicals company when you were thinking of the whole concept?
Well, it really is in some ways very similar to mining and refining associated with mining. The differences are that, in post-consumer feedstock, you have different sets of impurities, different combinations of elements. Normally lithium is never mixed in with nickel and cobalt. Geologically that doesn't really happen. So, there's interesting new, things needed and inventions needed on how to efficiently separate those. But one thing I think it is worth noting, many people think, recycling has this notion of, okay, well, if the thing you make out of recycling is kind of not as good as the first thing. It's sort of the brown paper, it's the sort of, ugly plastic. Metals are different. Metals are very, very different. And when we reprocess and recycle metals from an old battery, we actually have fewer geologic impurities. When you have to make the nickel pure out of rock, you have a long tail of stuff from the earth that was included in there. And people do a lot of hard work, the mining companies do a lot of work to separate that. The next time we refine it, it's actually more pure than the first time that it had to be refined. The analogy I think of is like, say you had water that you put through a fancy filtration system. If you put it through that filtration system multiple times, it just keeps getting more and more pure. The first time when you get it out of a well or something like that is the dirtiest water you're going to have. So very different than sort of plastics or glass recycling, where you have polymers and such.
Interesting. Well, when you see a list of all the critical minerals that you put up there, and how do you think about them all in the same kind of way, or are there like two brackets? What I'm thinking of is something like, say, nickel or cobalt, where it might be easier to then refine and get out initially, but something like a specialty chemical like lithium might be a bit more difficult to turn it back into the hydroxide of carbonate, to get it back into the battery. Do you think of them in two brackets like that, or are the principles kind of the same?
I mean, the chemistry is a bit different, but I'd say we generally think of it in a similar way. I mean, our premise is to try and create products out of everything we bring in. So, not generating any additional waste streams, but, forcing everything to become a product. And, lithium is such a less mature commodity than nickel. In the market, it's very, very different. And, recycling has a chance to meet actually a much bigger percentage of the sort of gap, I would say, with lithium than it does with nickel.
Interesting.
So in that way, I think lithium recycling may be, more percent relevant in the overall market sooner. Cobalt, by the way, maybe just to mention that one, I see cobalt recycling as, even more relevant still. We are sourcing 100% of our needed cobalt. Actually, we have excess cobalt. And this is partly because of the technology shift ongoing in battery chemistry toward less cobalt. Everyone has been on a quest to low cobalt cathodes or cobalt-free chemistries. And it's kind of a fascinating shift that's happened because recycling and looking at secondary feedstocks, you're looking in the rearview mirror technologically. So we're pulling in a lot of cobalt, and then the demand on cathode is reducing in cobalt. I almost cringe now when battery cell makers are so excited about their cobalt-free cathode, and I'm thinking, oh, geez, this is great. Now we have to spend more money to take all the cobalt out to create this, cobalt-free cathode material that actually has higher environmental impact, even though it's supposed to be an ESG solution. So anyway, cobalt is interesting. I think that's going to see a bigger shift.
When you look at it's interesting you're saying you have to almost create, I guess, recycling gigafactories to go alongside the gigafactories that are being built. And our numbers were, as I mentioned before, 314. Really, I think we're going to at least 500 worldwide. They're going to be active over the next sort of decade. We'll know in 10 years, put it that way. But it's going to be that kind of level. So this kind of build out of battery cell capacity isn't slowing down. Of the 500 gigafactories, how many high-level stuff, but recycling facilities do you think we'll need?
Well, I think recycling facilities won't stand alone, in my view. I really think we need to imagine that whole supply chain. And so when you look at the recycling piece itself, it's critical, it's important, but if you don't link it to material remanufacturing, at least somewhat close by, at least on the same continent, I really think you've missed a big opportunity. So, ultimately, I believe, we need to, and the world will, balance itself out in the supply chain. Moving all of the bill of materials for batteries, from Asia to North America, I don't think is tenable in the long term. It's not really economic in the long term. So in that way, I think those gigafactories, will be balanced, with regional facilities to make cathode and to do some of the recycling needed. That's the big shift that hasn't happened yet. We're starting to get visibility and a lot of acceleration on gigafactories, but I think now there's almost, no offense to this group, but I think there's almost too much focus on the gigafactory itself, and I think we need to broaden.
That's the event.
Yeah,
that's the event.
But I think it's important that we broaden the definition.
Yeah.
Maybe I'll say it that way, of what a gigafactory is. Obviously, supply chain and the metals that feed the battery cell assembly factory are so important. It's actually a bigger part of the economic, pie chart right now. So I think if we start to look at the gigafactory as everything needed to make the battery, along with the long tail of stuff all the way from, from the mine or from recycling, that's what has to get scaled.
Going back to 10 years, probably, back to the future, really, probably for you, when the gigafactory concept, it might have been 8 years ago, you can tell me more, but when the gigafactory concept came up, could you just walk us through kind of the world we lived in then from an industry perspective and how that idea came about?
Yeah, it was, it's really phenomenally recent when you think about this. 8 to 10 years ago is not, it feels in one hand like, lifetime ago and like we're old men here, but, it's really not that long ago. And at Tesla, the first gigafactory concept was kind of born out of necessity. I wish I could say we had this brilliant foresight and we were planning, the future of the whole market, but, in a lot of ways, we just were looking at what absolutely had to be done to meet the needs for Model 3. And I remember quite clearly, sitting around as we were trying to, figure out the supply chain needed for that vehicle. Back then we were, aiming to build a few 100,000 cars a year. This was, hugely ambitious. We weren't even sure if there'd be customers. Most people doubted there would be. But at 300,000 or 400,000 units a year, it needed more lithium-ion batteries than the whole world produced. In the year that we were sitting there, on some table contemplating this. So, in that type of market, going out to source from the market, doesn't really work. You can't go to existing markets and say, oh, by the way, we'd like to, buy as much as you've made in total. So, I and others really saw that as an opportunity to kind of redefine the market and to, drive the investment into bigger economies of scale, and to say, okay, well, if we're going to drive this demand, we should architect it in a way for the greatest cost efficiency, for the greatest synergy with the vehicle assembly locally. And that all kind of came together to say, well, somebody has to make a battery factory that's this massive thing that's never been done before if you want to make this many EVs. They go hand in hand. And it was patently obvious when you looked at the numbers needed for the supply chain, but the result of it was kind of unintuitive and terrifying. So that was sort of the beginning of it. The vision, again, was to integrate a lot of it, to vertically integrate as much as we could. We had hoped, frankly, to integrate more of the supply chain way back then, but it proved a little too difficult. It was sort of a bridge too far, on the first step of this, and building, one factory and moving this to North America where it had never been done before, where there were a lot of firsts. And trying to move the supply chain at the same time was a little too risky and too much. But I feel like that still hasn't really been solved yet. I know people are making plans. There's movement and talk of bringing cathode and other materials to North America. But as we sit here today, in the graphs you showed, there's no color on those bars. You look at North America and metals refining and battery bill of materials manufacturing, it's pretty much sitting at zero.
Yeah. When you went to your suppliers back in 2014 and said to them, we want you to supply us the entire world's production of lithium-ion batteries, please. What was their reaction?
Yeah, it was it was not always super positive. Usually those discussions started with some level of trying to convince them that there would actually be a demand for electric vehicles. It was pretty painful because we'd have to, on one hand, the goal was secure investment for tens of gigawatt hours of capacity, and then on the other hand, we'd be walking into a room where people were freaked out that EVs weren't even going to happen. So lots of discussion of Nissan Leaf and how that had just failed and nobody wanted EVs. So it kind of started with, justifying, trying to explain the market, sell. It seems ridiculous today, given where we sit in the market, but only a few years, 10 years ago, we were trying to sell to suppliers and explain to them that there would be demand. And, I still think we see this actually in the mining industry. I feel actually some similar feeling when we go, even today to talk to mining companies. They still, I think, are more skeptical that any of this is real. They're kind of like, yeah, we'll see it evolve over the next 10 years and we'll respond when we get there. But that was the case with battery manufacturers and component manufacturers, the first wave of building the first Gigafactory.
Interesting. I've got some questions here. We can go through and see what you can answer. First, that's an interesting one. Why choose Nevada as a location?
Why Nevada's location? Well, there was a giant, complicated, site selection matrix, as all these things go. Whenever companies are looking at new facilities, there were many reasons, but ultimately proximity to where Tesla's engineering headquarters was, and of course where the first big vehicle factory was in California, was a key factor. And ultimately, I think in hindsight, it was quite decisive that we did that to make it successful. It was insanely difficult to get that factory online. And one of the bigger challenges was the lack of human expertise in these areas in North America. You can't just sort of teleport this whole industry in, without a whole bunch of, training and getting a new workforce up to speed. So, having close proximity to a lot of engineering talent and being able to redeploy engineers, who used to be working on, who knows what, whether it was software or IT or vehicle engineering, and saying, okay, well, actually now you're going to come help us make a battery factory work and actually run appropriately. Being able to do that in the same time zone and within a 3-4 hour drive was really quite important. And I think it was more important than saving perhaps another ½ cent per kilowatt hour of electricity, or perhaps having a tiny bit lower labor cost or something like that.
Interesting.
The world is in a different place now, and I think now we need to be focused more on marginal economics and scaling. But the first one was really about making it work. And the bigger risk was that it just wouldn't work properly or wouldn't start on time or even later than it actually already was.
Next question. What are the challenges in setting up a cathode material operations in the US?
There's some very similar parallels to what I just described. The US has lost or, atrophied a lot of its chemical engineering and chemical processing industry. We still, of course, do a lot of petrochemical processing, but when you look at metals refining, metals processing, chemical manufacturing, these are industries that have kind of moved out of the US. So when we look at building and bringing a large cathode manufacturing facility to North America, we have to, again, look at knowledge transfer, training, understanding how to, find the appropriate workforce, even the supply base to build the equipment for the factory. It's sort of, this never ends, really. And, you build a cathode facility, and then you start focusing on all the different, pieces of equipment, and who makes those, and where do those come from. So, lo and behold, a lot of that supply chain also isn't in the US. We have to start, making sure we have support from Asian companies, who are maybe making kilns or different components. This has to happen. None of these are excuses not to do it. There are reasons why, it might be difficult and there are challenges. But, those are the ones I'd say we're focused on right now.
There's another interesting one that always used to pop up, actually, a couple of years ago. What is required to improve battery collection logistics? Should auto OEMs be required to shepherd used batteries to recycling facilities? You'd love that, I guess. But, yeah.
Well, this is actually a very topical one. There's a lot of different states and jurisdictions worrying about this. I think we need to be careful that we don't incur more cost on the EV owner for recycling. If I just sort of thought selfishly about what's the easiest way to get more batteries for recycling, sure, charge money, have it delivered to our doorstep. But I don't think that's solving the bigger picture, which is how do we, get more people driving and owning EVs at lower cost. So personally, I don't think we should put more cost burden on EVs, to facilitate recycling. I think it's really, incumbent on the recycling industry and all of us working in that field to figure out how do we make it more efficient? How do we make it cost positive so that there's positive value going back all the way to the EV OEM, to the owner? And as soon as we can make it an economic positive argument for all chemistries at every state of, location and charge, then it all starts to happen naturally. Right now, it's kind of on the margin or slightly negative in some cases, and then it's really hard. Then you're chasing people with a stick, trying to make them do it.
I guess this is where partnerships come into it, right? You've been on a tear the last 12 months announcing many partnerships. I guess, can you touch on that as well?
Yeah, and these OEM partnerships that you're referring to, we just announced a pretty significant, working relationship with Toyota just this week. We're really excited about Ford earlier, Panasonic as well. These are, I think, really key to make that more efficient. And when we can integrate and work very closely with the OEM, we can make it lower cost for them, for us, for everyone to aggregate and get those end-of-life batteries back. Toyota is particularly exciting for us because if you look at, again, kind of looking in the rearview mirror, historically, Toyota deployed a lot of hybrid vehicles even before the full BEV movement started to rocket. So those now are actually one of the largest battery fleets with wheels on them out there in the world, and we're very excited to work on recovering efficiently and recycling, reprocessing all those old hybrid batteries. And interestingly, you can actually very relatively easily take the nickel from an old nickel metal hydride battery, re-refine it, and move it into an NMC type cathode material for a lithium-ion battery. So we can use those same nickel atoms, quite a bit more efficiently and store, more than twice as many kilowatt hours per nickel atom by redeploying it into a different chemistry.
And my final question would be, what are your fears for the industry? What do these guys actually need to do to make it work?
Well, I'd say, I think one fear that we should all kind of keep track of is trying not to have, huge oscillations in this industry. We have to be on a steady and accelerating path to electrify all of transportation as fast as we possibly can. I mean, the world needs that. It's an imperative. That can be kind of screwed up by, these wild swings in commodity prices, by, wild swings in availability of different parts of the supply chain. And, my fear is that, our investment is way out of whack throughout that whole supply chain. I think it's right now probably over-focused on investing in battery assembly capacity.
Yeah.
And, that investment, it's needed ultimately. So it's not a question of do we need it in the long term, but if it runs ahead of the raw materials, it's going to get choked off, and you'll have big price volatility, which ultimately can end up kind of harming consumers' confidence in EVs. When EV prices skyrocket, everyone says, well, geez, these things are not affordable. They aren't really what we thought they were. They're not working. But in reality, it's more gyrations in the market trying to get itself scaled. So anyway, that I think is probably my bigger fear of the overall state we're in, is how can we do this 1,000% growth and do it without huge price shocks that hurt the whole market.
No pressure, I guess. JB, I've really enjoyed this conversation, and I think it's been excellent to frame the whole thematic that we've now all got to go through, right? So I'd like to thank you for being our guest of honor, and please thank JB Straubel.